In today's video, we're going to do an introduction to theoretical versus experimental probability. So the probability is a ratio expressing the likelihood that a certain event will occur. The probability of an event occurring is the ratio of favorable outcomes to the total number of outcomes. An event is a subset of the sample space. So, for example, flipping heads on a coin, that would be an example of an event. That's something that could happen. Drawing the Queen of Hearts is an example of an event. That's something that could happen if you're pulling cards from a deck. Being born a female is an event. There's a certain probability that you will be born or that somebody would be born a female. Owning a dog is to take a poll or a survey of the class. Owning a dog is an event that could happen. Rolling a prime number on a number cube or on a die is also an event, or winning the lottery is an event. The sample space is the set of all possible outcomes of an experiment. So, for example, flipping a coin once results in two outcomes, heads or tails. So the sample space would be heads and tails, and we can use abbreviations. So we could use those letters H and T. Okay. Outcome is the result, or a result. Quick vocabulary review. All right, theoretical probability. This is the exact probability that can be found with a formula. So the formula for theoretical probability is the number of favorable outcomes over the total number of possible outcomes. So I like to think of theoretical probability as the thought probability. So I'm thinking about what might happen. So theoretical is my thinking probability. So if I think about rolling a die, it has 6 sides. So the probability of rolling a 1 would be 1 out of 6. One side on that die has the number 6 on it. So 1 out of 6 is my probability. Rolling an odd number, so if I think about a die, the odd numbers on the die are 1, 3, and 5. So that would be 3 out of 6, or 1/2. So half of the numbers on the die are odd. Rolling a prime number, so if I think about the numbers on the die, 1 through 6, my prime numbers would be 2, 3, and 5. So 3 out of 6, or 1/2. So half of the numbers on the die are odd. Notice I didn't actually do anything. I just thought about those probabilities, and I came up with these fractions. Right? Experimental probability is determined by carrying out an actual simulation or an experiment. So the formula for experimental probability is the number of times the desired outcome occurs over the total number of trials in the experiment. So we're going to conduct a quick experiment right here by rolling a die a couple of times, 10 times, and then we're going to record the results and calculate some experimental probabilities. So first time I roll the die, I get 4. So I'm going to put a tally in 4. Second time is also a 4, so I'm going to put another tally there. Third time is a 1. Fourth time is a 1. Fifth time I have a 6. Another 1, a 3, 1, 2, 4, 5, 6, 7, 8, and I get another 1, 9, I get a 5, and last time 10, I have another 4. All right, so I conducted my experiment by rolling my die, and so now I want to think about what is the probability of rolling the number 1. Well, from my experiment, I have 4 1s out of 10 rolls. So my experimental probability would be 4 out of 10. And if I simplify that, 2 over 5 to get my final answer. All right, rolling an odd number, my odd numbers are 3, 5, and 1. So I look at the number of tallies that are either in the 1, the 3, or the 5. So I have 4 tallies here, another one here, so that's 5, and one more here is 6. So the experimental probability of rolling an odd number is 6 out of 10, or 3 out of 5. And then the last one we're looking for is the probability of rolling a prime number. So my prime numbers are 2, 3, and 5. So I don't have any tallies in 2. I have 1 and 3, and I have 1 and 5. So that would be 2 out of 10 came up as prime numbers. And if I simplify that, my theoretical or my experimental probability of rolling a prime would be 1 out of 5. Notice these numbers don't really match. They might be close, but they're never going to be exactly the same unless you get very lucky. So typically, theoretical probability and experimental probability are not going to be exactly the same. Quick recap, theoretical probability is what you think about, and experimental probability is when you conduct an experiment.